Imagine typing a command to trigger a series of tasks to build out your WVD infrastructure. Today, I'm going to show you how it can be done with Terraform. Hello and welcome everyone to my session on Write, Plan, Apply Terraform for WVD. My name is Jen Sheerin, and I have decades of experience in infrastructure. I am not a developer. Earlier in my career, when things were much smaller, it was easy to do next, finish a couple of times, and the job was done. It was about 8 years or so when I realized that wasn't going to work anymore. It was right around that time the word agile started being used a lot. And lucky for me, I had already been using some scripting, mostly PowerShell, to do what I needed. At the time, I worked at a company that chose to use Ansible. And somehow I managed to avoid getting involved with that and stick with PowerShell because there is only so many hours in the day and my focus was on Citrix. So I had the mindset that infrastructure as code was essential, but I didn't find a tool I liked until I discovered Terraform. And before I share with you more about Terraform, briefly a little more about me. You can see I'm active in the community. I'm a Microsoft MVP awarded in the Enterprise Mobility category and a Citrix Technology Professional, or CTP. I am the founder of the US Windows Virtual Desktop User Group, and everyone is welcome to attend the monthly virtual meetups. I am a Citrix User Group Community Woman in Tech Mentor and one of the CUGC Tampa Bay Leaders. I work as a post-sales senior delivery engineer focusing on end-user computing, especially Microsoft WVD, Citrix Virtualization, and Citrix Networking. As a delivery engineer, easy to use, repeatable, less manual intervention, version control code on infrastructure, and trackable are all valuable to me. You may be wondering why I use Terraform, especially since Project Bicep is easier to use than ARM. For me, I also like the multi-platform and cloud agnostic benefits of Terraform. So first we'll need to do some level setting with some of the basics of Terraform. I'll go over what we need to get started. Then I'll show you my methods for deploying WVD, including the supporting infrastructure, and along the way, I'll highlight some key points. As I talk about some basics, for those of you that already know Terraform, please be patient. Terraform is an open source templating language created by HashiCorp. The initial release was in 2014, and the current version is 0.14.10. Some of you may have already heard of HashiCorp if you are familiar with Packer, which is another HashiCorp product. Azure Image Builder is built on Packer. When I started learning Terraform, I found a wealth of information and tutorials on the Terraform website, terraform.io, and I highly suggest you taking a look if you want to learn more. According to the website, Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. So it's a tool that can be used for provisioning. It is not used for configuration of infrastructure. What do I mean by that? If I were using scripting for deployment, I must script what I want and the how or directions and the order. In Terraform, I define what I want in HCL language, and Terraform takes care of the how to produce the desired state. Cool, right? So how does that work? In part, there's something called providers. The provider is responsible for understanding the API and interacting with the resources. As you can see, there is an Azure provider along with several other vendors. A few months ago, the desktop virtualization resources were added to the Azure RM Terraform provider. And all of us in the WVD community was really excited because that meant that we could now use Terraform to deploy WVD. Before we dive a little bit further, you should know that Terraform has a state file. When you use Terraform to deploy infrastructure, it stores information in a file with the extension of .tfstate, which is a JSON file. It contains information on what Terraform has deployed and is used in future deployments to apply changes incrementally. On the screen is an example of the state file from the deployment I did for this session. Terraform state can include sensitive information. By default, Terraform state is stored locally. But locally does not work well for collaborating with a team, and you should store Terraform state in a common area. One option is to store Terraform state in Azure Storage. Another is to store Terraform state in Terraform Cloud. For the demos today, I use the default for simplicity, but it's not the best practice. When I first started learning Terraform, I found versioning a bit confusing, and I had some errors. If you look at the Terraform block here, you will see that the required version is greater than or equal to 0.14.0. And down here, I'm setting the required Azure RM version for 2.4.7. So let's see what happens when I initialize Terraform. I'll scroll up a little bit so we can see a little bit better. Aha! So I have a warning letting me know that the expressions are deprecated. I also have an error that my version is unsupported. Terraform is really good about giving me feedback and letting me know how to resolve my issue. It even says this configuration does not support Terraform version 0.13.5, and I should choose another. You saw me earlier run the init command. Before I can run other commands, I must run Terraform init to initialize the working directory. Running Terraform plan will show my changes, and after reviewing the changes, I can run Terraform apply to make the changes. And since this is my lab, when I'm ready to start all over, I'll run Terraform destroy to remove everything. Let's go over what I need to get started. To start using Terraform on my Windows machine, I need to go to the Terraform website and download the exe. There's just one file, terraform.exe. I need to make sure that the terraform.exe is added to my path. And don't worry if you have other versions like Mac, Linux, Solaris, they're all supported. Not required, but I like to use Visual Studio. I find it easier to use and it's also free. I also installed two Visual Studio Code extensions, the one from HashiCorp, HashiCorp Terraform, and the Azure Terraform extension. Before we move on, I want to show you another thing about Terraform init. When I run the Terraform init, it creates this hidden .terraform directory that is used to cache the provider plugins and all the other bits. Now, I had to view my hidden in order to see this directory. Terraform reads files that have .tf extensions. I can put everything in one file, but that makes it difficult to read. Typically, there's a file structure of a main.tf, variables.tf, outputs.tf, and providers.tf. But it also makes more sense to me to set my variable values in a separate terraform.tf-vars file. This way, I can modify just the .tf-vars file to make changes for my different environments. I am using modules for collections of reusable files. Terraform will look in all the folders within the initialized directory. As you can see here, Terraform found the modules folder and all the subfolders as well. I have a module for building a single Active Directory domain controller in Azure. I have a module for the shared image gallery and one for storage and of course for WVD. The backend was initialized and then the providers that are needed as well. The random provider that you see here is needed because I used the random to create a random string to randomize my storage name. Terraform installs both the Azure RM provider and the random providers for me during the initialization process. So if you remember from my graphic in the previous slide, you will know up next is running Terraform plan. And immediately you will notice that there is a log file created for our state file while in process. Let's scroll up to the top so we can review the plan. And there's a lot of items here because we're creating out the whole entire infrastructure. Taking a look at the constructs of the resource block, I have a resource type and a name. The type is dictated by the provider, in this case, Azure RM underscore resource underscore group. The name can be anything. It is used by Terraform. So in this case, it's just example. The two things together become the resource ID that Terraform uses as a reference as well. Notice ID equal known after apply because it has not yet been created. And you'll see a lot of those. The location is my Azure region. And the name is the name of the Azure resource that will be created. So if I go in the portal after I apply my Terraform code and I look for the resource groups, I will see a resource group named WVD-RG. So as it continues to scroll along, we'll see the shared image gallery. It is created and the definition for the image is also added with the right resource groups and location and even some tags here. We can see the storage accounts for the file storage, and there's quite a lot of information that was automatically generated here. And notice there's also the green plus sign next to every item. That means those things are going to be added and now we're seeing the file shares. We have two file shares, one for MSIX and another for FS Logics. And there's a lot of known after apply here. You also see the random string that I used to create that unique name for the storage account. And now we're seeing the WVD resources, host pool, and the application group. And after those they are created, then they'll be associated with the right host pool. I also added a VM for Active Directory domain controller because in my lab I didn't have a domain controller connected. And you're seeing some PowerShell script that was used to configure the domain controller. And then I also built out a member server as well as a Dropbox. So you'll see a little bit of additional resources here going through that was not required for a WVD deployment. So altogether, I had 26 items to add in this plan. So that all went by pretty quickly. So let me show you what is in my main.tf files. At the very top, you see I list the providers, Azure RM, and I didn't put the requirements here because I have a provider.tf file that sets the required versions for me. On line 5, you can see where I start calling the modules. So I have a module for AD, and that is used to build out the Active Directory Domain Controller VM. Notice that this is listed at the top, but Terraform knew what I was doing, and it put that at a later time when we looked at the plan because those tasks showed up at the bottom. So the order was handled by Terraform. I have my location set as a variable. That's why you see var.location. So the variable is defined in the variables.tf file. You can also see that I'm referencing the modules, and some of them have some variables that I also set in the variables.tf file. I also added a log analytics module after I took the last demo, so we'll end up with some extra resources for the log analytics here when we do the next demo. You know what comes next? Terraform apply. So I type Terraform apply and we're off and running. I'm prompted to enter yes here, but if I want to do more automation, I can give it a switch of -- auto approve to make sure I don't have to manually type yes every time. I fast forwarded the video since we already reviewed it during the plan, and it took 20 minutes for the whole thing to complete. Woohoo! Now you can see, we go into the Azure portal and you can look at, there's my storage account that got created, and here are the file shares for MSIX and FSLogix. If we look at the WVD hub, here we can see that the host pool got created, and under the host pools we have the application groups, and we also have our workspace. So everything got deployed for WVD, and if we take a look at the shared image gallery, you'll see here's my shared image gallery, and there's also an image definition, and in the definition we also have the appropriate information for publisher and offer and SKU and even the operating system. So the final step for me is to do some cleanup in my lab. For that, I run Terraform destroy. So you can see that the items that are marked with the red negative symbol, because it's taking away those items, and there's also the red destroyed to let you know that you need to double check and make sure that you really want to do this, because this completely destroys everything. So as you can see down here, my destruction completed in 47 seconds. And I did have the few more items from the first video. I had 32 items destroyed because I added the log analytics after the initial take. So here you have it. If you notice, I didn't have a session host after the build was completed. And that's because I didn't build in an image into the shared image gallery to create a VM. For that, I used Packer, and I was able to create it in 40 minutes, and just a little bit more than we have time to talk about today. But I used a shared image gallery, and then I was able to create the session host for my host pool. I've talked about a lot of stuff today, and you may have seen other options to deploy WVD. Well, hopefully you were impressed by the 20 minutes it took me to get this whole thing done. I showed you that Terraform maintains a state file and used the basic commands of init, plan, apply, destroy. There are other commands, but these are the main ones. I went over the file structure and modules, and we talked about .tf files and how all the subdirectories are initialized when you run init. I went over the use of variables, and I put all my variables in the terraform.tf vars file. So I have one file to change because I can keep reusing my code. I broke down the resource blocks to show you how it is written. And we talked about using modules for grouping, and I deployed WVD with the supporting components in 20 minutes. So now I have time to relax. Maybe you're wondering why I didn't take it any further and do some scripting for app installations. Well, that's because I was thinking about integrating Terraform with the Azure DevOps, and that would make it more powerful. And I also want to use managed identities. So that's what's next for me. And I hope that I've inspired you to work on your own Terraform project. I want to say thank you for listening to me talk to you about Terraform today. And I've put all the code that I use to build out the infrastructure on my GitHub. So feel free to go grab it and get started on your own project with Terraform. Reach out to me on socials. If you have any questions, you can always get a hold of me. And thank you again for attending. And a special thank you to Dave and Crystal for organizing this great event.